Hello. In this video we're going to talk about sets. Now a set is just the same definition as we find in mathematics. It's an unordered collection of distinct elements, and we have some advantages in using a set interface because the set adding an element has no effect if the element's already in the set. Removing an element that isn't in the set is silent. It's more efficient to test to see if an element is in the set. From high school geometry we remember Venn diagrams, and here's the union, the intersection, and set difference. We're going to represent all three of those things. There are basically two ways to implement sets. One is called explicit, the other, of course, is called implicit implementation. The explicit implementation relies on a bit vector, and it also relies on a base type. Each item in the base type has a bit of 1 or 0, depending on whether it's in the set or not. So here are two sets. The base set is the set of all capital letters, A through Z. There are only 26 of them, so that's good. We cannot use an explicit representation if there are an infinite number of elements in the base set. So in set A, if the capital letter A is in the set, then we give it a 1. If capital letter B is not in the set, we give it a 0. And the same situation for set B. So the union of set A and set B is if it's in either set A or set B, it's the united or the union of those two sets. Similarly, the intersection is if it's in both sets, and the set difference is if it's in set A, the set difference of set A minus set B. If it's in set A but not in set B, then it's in the difference. So of course there's an implicit implementation, and this is just a really normal way of representing sets. It is you list out the sets either in an array or in a linked list or somewhere like that, and you list the elements that are in the set. So here's an example of set A and set B, the same sets. To find if they're in the union, we have to do a little more work than with explicit representation. We have to set a cursor and go down the list of both lists and find out if it's in either set A or set B. So A is in one or the other. It's actually in both. B is in neither one. C is in set B, so we include it. D is in set A, so we include it, and so forth down the list. The same process you have to adopt for the intersection of set A and B, and here's the result. And the same process you have to implement for set difference. So you can see that the explicit representation is much more efficient. It's order constant as opposed to order n in most cases. In the cases where implicit representation is order n squared, explicit is order n. And especially when we're asking if it contains it. Now the only difference is whether or not the set is empty, because you can just go directly to the element and find out if it's in there or not. Of course, the problem is that the explicit representation has to represent, the base set has to be a finite set. So we could use a linked list to implement a set. It'd be fairly slow. there are data structures in the library that handle those operations more quickly. In fact, the Java library has two classes called HashSet and TreeSet, both of which implement the set interface. So why would you use one or the other? Well, a HashSet is slightly faster, somewhat faster. A TreeSet is used if you want to visit the set elements in some sort of sorted order that the tree encompasses. But both of those libraries are in Java, and they are useful. Here's the interface. And here are the methods in the interface, especially the ones add and contains are especially important. So how do you use a set? If you have a hash set or a tree set, you can list the reference type as a set. And in this case, a set of strings called names is equal to either a new hash set or a new tree set of string. And in either case, you could just add or remove elements like it shows here. You can test to see if it contains the element or not, and that's a true-false Boolean statement, Boolean method. You can also use an iterator to visit all the elements in the set. The thing about a set, though, since it is defined as being unordered, there's no guarantee that there's any certain order that the iterator will find the elements. It is guaranteed to find all the elements because the underlying implementation of a set guarantees that the iterator steps through every element in the set. You can't add an element at the iterator position, but you can remove an element. Again, it's not recommended. You can also remove from the set object, the set class, by providing the object itself. So when you visit all the elements with an iterator, you can either go with a for loop, a while loop rather, while the iterator has next, and then retrieve the next element. Has next, remember, is a question. Does it have a next element? Or you can use a for each loop that does the same thing as long as it has an iterator. So we have this little program that we're not going to ask you to build, but you know that the book Alice in Wonderland has some very strange names in it, like Jabberwocky. What in the world is a Jabberwocky? We don't know. But a dictionary has a set of all the correctly spelled words. So the process would be to read all the words from a dictionary file and read all the words from the book Alice in Wonderland into a second set, read them into two sets, and then print all the words in the second set that's not in the dictionary set, which are potential misspellings or the weird ones from Alice in Wonderland. So here's some code to do that. Read words from both the dictionary and the document, and then loop through and print the ones that are not contained in the dictionary. And here's the description of the read words method. So why would you want to use a set instead of some other kind of collection? Well, there's a couple reasons. First of all, it's faster. So it's efficient. It's easier to do unions, intersections, and set differences. And if you change the line 40 of the previous slides to use a tree set instead of a hash set, you would get the output in sorted order probably sorted by the words. So if you wanted to do bulk operations with sets, you have to remember that the contains or the add all or the retain all, the remove all, the add all, retain all, and remove all transforms the first set into the union. So you don't want to, if you're doing bulk operations, you don't want to change your original set into the union of S1 and S2. So basically what you need to do is create a new set type from set S1, and then, for example, if you're doing the union, you want to say union.addAll with set 2, intersection or difference. So next we're going to talk about maps, but that'll be in another video.